Welcome. All right, what's up, everyone? Tom here, and yeah, today we've got a different live stream than what we did the last week. We're not unboxing anything. We're not. Well, we are we're making something. We aren't strictly building a 3D printer, but instead, like I've announced, like it's in the video description and on Google Plus and Twitter and everywhere there, we are trying to do a walkthrough from an idea to an actual physical printed part. And like I said, this is not for the 3D printing pros or super experienced folks among you, but it's more like, if you want to share that with your uninitiated 3D printer friends or 3D printer interested friends, then please do so. Go ahead, and I'm gonna have I'm gonna have an eye on chat, so feel free to ask anything, any level of question along the way. I'll try to answer them. Volume is low. Volume, hold on, that might be a bit loud. Let me just crank that up. I can't. Okay. That's just gonna be as loud as it goes for now. Well, volume is low. You know what? I'm not gonna get that. If you tell me volume is low, then I'm gonna gain the crap out of this one. Okay, so let's add like 5 dB to that, and we should be a bit louder now. Okay, volume is okay here. Joe is here. Hi, Joe. Yes, we are using the Prusa i3 Mark II. I just don't want to have too many things go wrong today, and I know this one just works. Just always works. Now, yes, Prusa is a mod because he's kind of a good guy and helps keep the chair clean. So, yeah, so what we are trying to do today is I want to design a belt clip for my audio recorder. Let me just turn that second camera on. So right now what you're hearing is the audio from this Zoom H4n. It's basically like a handheld audio recorder, got XLR jacks in the back and microphone inputs and stuff. But the one thing it doesn't have is some way to carry it on your body. You either have to put it in a pocket or, well, that's basically it. So what I want to design today is a belt clip that goes on the 1/4" screw that's now holding the recorder up. That's like your standard tripod thread. And, just make a clip that goes on the back of that device and clips onto my belt. And yeah, now, like I said, noob stream. What that process usually involves. So I have an idea. I know what I want to make. Typically, I already have sort of an idea in my head of what that thing should look like, and I think that is the most important step in any 3D printer or any design for 3D printing, for manufacturing, for anything actually. Having somewhat of an idea of what you want to end up with before you start out. So typically, most of that happens in my head, or you could go ahead and just sketch out what you want. Because I kind of screwed up and didn't bring any paper and pens. Basically, what it's going to look like. So we've got the recorder on this side. It's going to butt up against this first flat part. Then we're going to have a wraparound, and then a clamp down here. So basically, this does that make sense to you guys? So basically, we're going to slide this side over here on a belt, cluck like that, and then it's going to sit, yeah, in that sort of clamp. So that's what we're trying to make. Now, the two variants of printing something is either design it yourself or look if it's already up there online, because that is a huge part that a lot of people miss. You do want to look if somebody else has done that or created that exact same design you want to end up with before. So I sort of know that and the exact design I want isn't out there yet, but let's just see. So typically, I guess it's kind of frivolous to go and to advertise Thingiverse, but let's just check Thingiverse, Thingiverse, and see if they have something that is like a generic quarter-inch 20, or what is it, quarter-inch 20 belt clamp. Let's see what we can find with a belt clamp. So yeah, that has nothing to do with what I want to do. So let me see, belt clip, because that was obviously for a 3D printer belt. Sort of, you know, if you want to carry golf balls around, you can sort of do that. So right now it kind of doesn't look like I can get the belt buckle there. Right now it sort of doesn't look like we've got anything that even sort of matches it. I could go ahead, video out of focus, this one? I could go ahead and check like the more premium sites, like my Mini Factory, for example, and see if they have anything already designed. But typically those moderated sites do more of a complex design, or have more of a focus on more complex designs, like complex props and figurines and all that sort of stuff. So we're going to design it ourselves. Now, obviously, yeah, gotta know how to search. That is as always the biggest, you know, issue with finding 3D files at the moment still. There are some 3D printing or 3D file search engines, but they don't really work any better than what you can get on Thingiverse, Umage, and all the other sites. They're just combining all those search results into one and then show you a few images. That's not that much better than what I just tried. Let's try Money Clip. That's a good suggestion. Money Clip, because I'm not completely unprepared. I did try this beforehand, and what I ended up with was something sort of like a Money Clip. Now these actually look pretty much like I want to end up with. So for example, something like this. Yeah, so that's basic. That's the same base shape I want, but let's see. I don't think it's gonna have that quarter-inch 20 hole for it. So there's the 3D model. Yeah, so it's just a very simple clip, and it also has this little lip down here, which would rest against the recorder's body. So it's not. You could make it work. You could go in and modify it, but I mean, obviously, what I want to get at is we want to design something, right? We just want to go through the basic steps of how designing a part looks like. So yeah, like I said, I already have an idea of what it should look like. I've already designed it beforehand, so I can give you guys a bit of a more structured way of how to construct it. So yeah, basically 3D design. It's complicated. Well, it's not really complicated. It just comes down to what you like and how you want to approach things. So what I'm going to show you today is 1-2-3D design. If you've ever done anything with 3D printing, you probably know the program. It's by Autodesk. It's a relatively simple version of a CAD tool. It's you know, shifted towards like the professional CAD tools and its structures, but it's still like simple enough or dumbed down enough, if you want to call it that, so that pretty much everyone can use it. So that's what I'm going to be using. So if you want to go in an even simpler way, of course, Tinkercad, all those simpler tools are there. And if you want to go in a more CAD engineering way, Fusion 3D, or of course all the big CAD packages like SolidWorks, Autodesk, what's it called, Inventor, and those are the parametric designs that give you basically machine parts. But if you want to do like more artistic files, like the Aria print that we did in the MK2 build and unboxing and whatever live stream, this one was, I believe, designed with Blender. Correct me if I'm wrong, but yeah, that sort of design is what you're not going to be doing in 123D design or Onshape or SolidWorks. So Onshape is like a web-based version of the big CAD tools. OpenSCAD, yes, OpenSCAD. So if you are a programmer and if you really like typing things out and seeing that structured text-based or hierarchical basically design, then OpenSCAD is probably what you want to be looking into. I'm not a huge fan of it. I'm just faster with a mouse sketching things out. All right, so let's head over here. So we are going to take a look at 123D design. So 123D design is free. It's part of the Autodesk 123D suite, and it's free for personal or non-commercial use. If you want to use it for actually designing parts that you're making money off of. Same goes for Fusion. Fusion is free for makers. So basically, for all of you watching, it's probably free software as well. So I guess 123D design is basically the same as any other CAD tool. So you've got the same sort of interface, whether it's 123D design, whether it's SolidWorks, whether it's Fusion. It's also the same idea. So you started with a big blank canvas of nothing. In this case, 123D designs, it shows you the origin down here, X, Y, and then the Z axis popping out like this. Same coordinate system on any modeler, same coordinate system that you're going to see on your 3D printer. And in fact, that's exactly how I'm going to design my part, because I don't really want to go in and end up having to rotate or modify or scale even the part in the end. I just want to go in here and use this plane basically as what is going to be my build split in the end, just to give us a bit of a reference of what sort of design details we're going to have to look for, and what kind of issues you might run into. Yes, I did try Fusion. I didn't warm up to it that much yet, but I also didn't put a whole lot of effort in to really get used to it. All right, so 123D design does 123D do assemblies? It sort of does. It does multi-part objects, but assemblies are a bit beyond the scope of the program. So, like I said, it's 123D design is like a mix between Tinkercad and Fusion or a real CAD tool. So you can go in and you can grab primitives. So, for example, I can put a box in here, and boom, there's a box. We could go ahead and save that as an STL and print it if you're really into printing 20mm calibration boxes. I know I'm not a huge fan of that, so yeah. But of course, let's just bring that back and show you how the object-based modeling works. By the way, the perspective panning and a good tip here is you can also grab the cube up here, and that's gonna always orient the camera towards the horizon. So if you end up like with a super tilted view or anything, just grab the cube up here. You can also just click one side and get a nice view of one of the sides of your model. So let's say we want to, the basic idea of these shapes is you always want to combine several ones to end up with your final model. So I just messed it up. Let's try that again. So cylinder, and we can actually go ahead and modify the size of that cylinder before we place it. So let's say we want a radius 5 cylinder. It's going to snap it to the center. There we go. So now we have a cylinder on there. And what we can do is we could either combine these two to make like this sort of a shaped part, or we could just slide this one right in and do combine subtract. So we've got the main body, and then use this center cylinder as basically a cutting tool, as a removal tool, and make a hole like that. And that's the idea behind the solids-based modeling in 123D design or in Tinkercad. It's all sort of the same approach. But I tried, and it doesn't get me towards my belt clip because it's gonna have some curvy parts, some you know. There you go. There's the. I'm losing view of my desktop. There we go. There's the one half. There's the other half, the flat one. So it's gonna be really hard to just model that out of solid play blocks like that. So I'm not gonna go down that route. I'm actually gonna go the traditional CAD tool route and start out with a sketch. So typically, what your sketches are going to be are, well, the simplest form of what a sketch is going to be is a 2D representation of your 3D parts. So, what do we have that we could show here? We could probably show this part right here from the hex line. Okay. So this part right here, this is basically a hexagonal tube with an end cap on one end. So the basic sketch would be this base area down here, you know, with a bit of thickness, and then extruded along the end. So imagine like a spaghetti that's being pushed out of a die and then extruded along the end. That is how the very simplest form of sketches and sketch-based modeling works. Of course, you can add a second curve and make this one, you know, bent or have this one twist as it extrudes, but it's always going to have that base shape on its bottom, that base hex. That's like the base pattern for this entire thing. So yeah, what I have on my keyboard, these here, these are just my hotkeys for OBS Studio. So yeah, that's my Japanese. Well, it's just plain, you know, what is it? Latin characters. I have ugly handwriting, I know. Yeah. All right. Yes, James. What's his full name? X-Robots, basically. James Burton. Yes, I think he also uses 123D Design or Fusion. One of those tools, and he's actually pretty darn good at it. Check him out if you get the time. So what we're gonna try to do for the clip. So I've figured out the dimensions before, and like I said, I did sort of sketch it out and make a little plan here. Is we're only gonna draw one side of the clip and then add thickness to it. So let's start out by, you know, going on the what is essentially our build plate on that plane. So we want the side that sits flush against the body of the recorder. That's going to be 50 millimeters. And then we could go on and like sketch this around, you know, all edgy and stuff, but we're not going to do that. We're going to use a spline for that, which is basically just a curvy version of a line. We could use circles, but I found it works out sort of better if we go with the spline approach. So that's our whoops. Okay, I shouldn't hit escape. I should hit enter. Let's try that again. So we start at this point, go up here somewhere. Now obviously, whenever you're using something like a spline and just clicking stuff, it doesn't have to be super precise. And you know, this shape right here, we're going to be tweaking this anyways once it's printed. And this is just like a first proposal of what it could look like, what we could be doing. So, and let's get this one straight again. Yeah, so this one's curved. There's the clip down here. Now the problem is, if we were doing, is my computer lagging that much? Well, it's doing. I'll just show you guys. So it's doing 2 cameras. Those are 2 full HD cameras plus the webcam right there, plus the screen capture, plus H.264 encoding. It's sort of a lot of stuff. Let's just turn all of that off again. And it's just a dual core laptop from 2012. So it's not the most beastly machine, but it still works. Yeah, so we've got the basic shape. Now, obviously, we can't just print this. We've got only a single line right here. This doesn't give you a volumetric design. So What we'll need to do is we'll need to add thickness to that. So what we can use for that is the offset tool. Basically, we select the sketch we just made and we tell it how much of a wall thickness we want to end up with. So I went in, I tried a few things out. So around 5 millimeters should be a good thickness, and we can punch that number right in, hit enter, and that's going to be precisely 5 millimeters from the outside spline. Joe, by the way, or for anyone on stream, the feature where YouTube highlights someone's name is only when you are mentioned. So not everyone sees that, only the person who is addressed for that one chat entry. So let's move on. So we've got our spline done, or our wall thickness. So you can kind of see how this goes together. But with any CAD tool to actually create a 3D shape, you're going to have a closed surface. So we could either close it off down here and we'd have a solid brick, or we could go in and close this one down here, and then close it down here. And basically, think about that like having water poured in the center of the sketch, and if there's any spot where it can run out, that's not going to work for an extrude where it extrudes a solid a solid block of material from that. Can you run a 3D printer on a laptop from a laptop? Yes, you can. You can connect each and every 3D printer through USB. This one too, it has its USB plug up here. We'll get to that in a second when it's time to print something. We're actually going to use the SD card. There are a number of pros and cons to each way, and I'll try to explain a few of those. But those two ways, USB and SD cards, aren't actually the only ways to control one. Is this based on extrusion width? Yeah, kind of. And also we are going to get into that. What you need to keep in mind when it's time to slice your files, particularly for prints like these where you have a set wall thickness and need some sort of mechanical strength and stiffness to your part. We're going to look into what you can do in your slicer to actually make a part that is stiff, strong, and doesn't fall apart. That's the wrong camera. There we go. Okay, so we've got our closed sketch, and 123D Design actually shows you that it's closed by filling it in with this light blue color. And what we can do is we're going to exit right here, and we're going to reset the camera so it's not tilted. Come on, there we go. And 123D Design gives you a few different options. So you can either click the sketch and go extrude right there, or you can go where is it, not under transform, under construct, extrude, or modify, press pull. It's basically all the same idea. You take a shape and either drag it out to construct a solid, or if it's on another object, we're going to see that in a second, you press it in and that creates a void basically. So my height of this part is going to be 30 millimeters, not use those, 30 millimeters right there, and that should be a good size so that it's got some strength as we add the mounting holes, and also is sort of not too wide so it doesn't block up the entire back of the Zoom 8 for end recorder. Yes, so you can run a 3D printer on pretty weak hardware. In fact, the Raspberry Pi itself, which runs Octoprint, is rather weak itself. What is it, 800 megahertz or something? It's really not a whole lot of processing power. Question from chat, is that filament on my wall not degrading? It's not. It's actually holding up pretty darn well. I did sort it a few days ago, so all the top up here is PLA. All this stuff in the center here is like specialty filaments, PET, carbon fiber, PVA actually. That PVA still prints. And on the bottom, I've got all the engineering filaments, all the Tallman stuff, T-glaze, Invent, PEK, polycarbonate, all that stuff. But I also have a dehumidifier in here, and this room is generally pretty cold, so it's not like a moist sauna in here. It's more like a cold storage room basically, and that's ideal for filament. I've never had problems with moisture, other than with the nylon, which does take up water. Whatever you do. Okay, sculpt it out of clay and use a 3D scanner. That's also an option, but probably more work than what it's worth. Yeah, so we've got our money clip done. So right now you could go in and print this and use it as a wallet replacement. Us Europeans will never know why people use money clips, because we have coins that we keep in our wallet. But what we need to do is we need to add a hole for the center screw. So this is the screw. Where's my lens? There's my lens. Let's see if we can get this in focus. There we go. That's the screw that we're going to be using. That's a standard 1/4 inch 20, I believe, tripod screw. Now, what I had laying around here is some calipers. If you want to do design, if you want to do 3D design or 3D printing in general, get one of these. Many people will recommend the digital ones. I actually prefer analog ones with a dial. These aren't super expensive. These are like 15, 20 bucks, and they are super, super helpful. If you want to get the digital ones for like 10 bucks or so, also a good choice, but get some. Get just something you can use to precisely measure. You can use to measure filament, you can use it to measure your prints and see how far you're off and how much you need to adjust to actually accommodate for the correct dimensions. Yeah, get some. Whatever it is, get these. Super cheap, super helpful. So this screw, I sort of know the dimensions. It's supposed to be 1/4 inch, but with the imperial screw size, you never know how large it's actually going to end up. So let's get that focused. So I'm going to start out by measuring the threads on here, and that's slightly overexposed. That's okay. So we're just below 6 millimeters. So it's a nominal 1/4 inch, which is 6.35. So we're 1/2 millimeter below that. So just to be safe, we're going to make that a 7 millimeter hole. And for the top screw insert, we're actually going to make an indent for that. Let's just see that it's just below 12. So yeah, I know it's blown out. I'm trying to get the... that should be better. This one is slightly below 12. So we're going to make this like 12.5 or 14. So we should be good to go. Also, these are super helpful if you just want to get a quick reference of how large something is going to be. So 50 right there, or if you're like, how large is it? It's like 5 millimeters. That's the wall thickness it's going to end up with. All right, best bed surface. That's PEI with sticky tape on the back. That stuff is magnificent. Yeah, so let's move on with the design. We need to make a hole. Now I've checked. Let me actually get the. How do we do this? Like that. I've actually checked. So there's the recorder, and the clip is going to fit right there where the tripod is screwed on right now. And this thing up here, this is actually the external microphone input, so we don't want to cover that up. Now, I did measure beforehand. I am going to measure right now again. So the screw is like in the center right there. This might make some noise for you guys. I'm sorry. So right there, that's like the distance we need to stay away from, and that's 40 millimeters. That is 40 millimeters from the. Let's get back here. 40 millimeters from this edge right here. This edge right here to the headphone plug that is going to be over here. So, or well, from the screw to the headphone plug. So let's just keep that in mind while positioning that screw hole. So this is like a 25 millimeter grid. That would be somewhere. Let's see. Yeah, we should be good unless we create the the screw hole somewhere right down here, we should be good. Now, 1 to 3D design is sort of sketchy on actually positioning stuff correctly. So what I like to do for actually positioning things somewhat precisely or centering things is just create a sketch to align things and then create the actual sketch on top of that. So what I'm going to do here is I'm going to actually select this plane because we made this one flat so we can draw on it. I can't actually draw on these surfaces because these aren't flat. It won't allow me to sketch on there, but this one back here is perfectly flat, so we can create a new sketch on it. And as you can see, the plane has shifted and the grid has shifted to where the home, the 0 point, is down here, and it's actually now aligned with this backside right here. So we've still got the polyline selected, and I'm just going to draw a quick. Let's do it up here. We're just going to draw one single line down here, and it's snapping to the grid itself. That's okay. One line here, and that's going to be to align the screw hole because it will pick up on the center of that line to center it on the clip. Now, same thing as before. We're going to do the circle sketch on here, and as you can see, it snaps to the center. And what do we say, 7 millimeters just to be safe. So 1 to 3D design does let you punch in numbers from many dimensions directly. However, it doesn't let you punch in positioning directly. So 7 millimeters, that should be good. There we go. So same tool as before. Actually, let's delete this line first so that it's not breaking up the circle. Same tool as before. Just go in here and use the extrude command, and instead of pulling this thing out, which I guess would work if you want to cut a thread on it, I'm just going to push it in and it's going to turn into a cut automatically. Let's confirm that, and there's our screw hole. I should mention how holes come out smaller in prints than CAD dimensions. Yes, yeah. So that's actually quite a tricky topic. Now, screw holes tend to come out a bit smaller than what you're drawing up in CAD. It's all about the tolerances. It's sort of about how well your printer works, how well it is tuned in, how well everything is working together. Most of the times, I actually prefer to not oversize holes that much. Or just lightly oversize them and then drill them out with a drill bit. That's going to give you really smooth, really strong prints, or holes in that case, and also is going to have you centering the holes where you want them. Now, this hole that we just created, this one right here, is will have the layers stacked like this, one after the other right there. So depending on print your hole. So for example, let's say we were printing this one with, okay, now that I need to rotate it, it doesn't work. Let's say this side right here would be facing the print bed. So we'd have the layers basically perpendicular to the board's axis. That would create a different fit situation. Typically though, with a well-tuned printer or a printer that comes with good print profiles, you are going to get holes that are at least within 0.5 millimeter or 1 millimeter of diameter to what you're actually specifying in your STL file. And if not, you can always slightly drill them out. ABS shrinkage just makes everything bigger. ABS shrinkage isn't as much of a factor as you might think. Both ABS, PLA, PET, all of them shrink, but by a very, very small amount. And it typically doesn't affect your print dimensions that much. So we've got the through hole, we've got it through the outer clip and the backside right here. Now what 1-2-3D design lets you do is you can just go in, take this sketch and make it bigger. There you go. And now we can create our indent on the opposite side and our through hole back here so that we can screw it in. Now, what we will need to do, if I had a middle mouse button on this Logitech mouse, I could actually pan, but it won't let me. What we can do right here is we can add a dimension, just like in a real CAD tool. Look at me, I'm a real tool. If I can click this thing. There we go. Okay, so this one is, I don't know if it's my computer lagging or it's probably both. I just want this dimension to, come on. Okay, this is going to be tricky. Now, you can add dimensions to this. Oh, there you go, now it's there. And we can double click this to actually change it. Like we measured before, this is like 12 millimeters or so, so we're gonna make it 14 to give it a bit of leeway there. 14 millimeters, hit enter, and that's gonna scale it right down to the exact size we want. So we're actually gonna do a mixed approach of what we just started out with the solids modeling, where you combine different shapes into each other and subtract one to the other, or combine them or intersect them, and this sketch-based one. So from this sketch we're going to create a solid, and then we're going to move it to the position we want, and then subtract that from the rest of the parts. So we're going to yet again go in here and actually done here. Yes, we do not want to dimension anything else. There we go. So we're going to go in and extrude this part right here to 20, just to make the dimensions easier. Nope, actually missed a step. Let's try that again. Extrude 20, and instead of what 1-2-3D Design and many CAD tools will try to do is to merge it to whatever bodies, whatever solids you already have on there, and that doesn't allow you to move them around afterwards. So what we're going to do is a new solid, which will allow us to move this cylinder right here independently from all the rest of the part. So yeah, if you click apart, we get the control bar down here. We can move this thing, and we are actually going to move this by 23, I believe, because I did measure out beforehand how far this screw head will actually, let's focus this up, how much space will actually end up with. Camera, don't let me down, come on, don't let me down. There we go. How much this screw head will actually insert into the body of the recorder, and how much this thing is going to stick out on top. And that's just roughly 3 millimeters that we have of material. Come on. 3 millimeters left on the clip to give us the maximum screw depth, basically. So that's that. So we've got the part moved into the position we want. That's going to create the divot on the opposite side of the of where the recorder is going to sit. So that insert for the screw head plus a hole for the other side here to screw it through. And again, we're going to combine this. We're going to say target mesh, our main body, and we're going to subtract this thing from it. And there's our part. So yeah, I guess this could be a finished part. This could be something you can use, you can print, you can make work. But we're gonna add a few more features. Yes, a clip, but for what? Just to re-explain it for all of you who join in later. This is my Zoom 8 for an audio recorder that's recording things right now. I don't have a way to clip it to myself while I'm recording stuff. So I don't want to jam it in my pocket. I'm going to replace, well, this Gorilla Pod it's mounted on right now. I'm going to replace this thing right here with a belt clip so that I can clip it to myself when I need it. For example, every time I record a regular video, I've got that thing in my back pocket and it's kind of huge. I just want to have it clipped on my belt, and got it, got it sorted away, got it tucked away. Also, for things like TCT show that I'm going to be at the end of this month, I'm gonna have the recorder on my belt, microphone cord going up, and looking all professional and stuff. Will I be putting the model into the YouTube description later? Yes, if you want it, sure, why not? I usually publish the stuff I do publish on the public domain. So yeah, sure. Now, let's have a look at how printable this thing actually still is. Now the main problem here obviously is overhangs that you're looking at. So you've got, let's just get rid of these sketches because we're not going to need them anymore. Okay, I could have deleted a bit more, but anyways, let's have a look at overhangs. So typically smaller holes like this is a 7mm hole, aren't going to be a problem if you print them like this, with the layers aligned like that. The top layers that have the strongest overhangs up here will sort of curl up here, but that's usually going to sort itself out once that top layer comes in and actually bridges everything. So that's going to be a hole that should turn out pretty well. Now this one over here is a whole lot larger. It's a 14mm hole, so it will have a lot more area up here where it's going to be unsupported for the longest part of the print. I do trust the Mark II enough to say that this should come out well, but as always, stuff like these, if you're unsure about whether or not it's going to print, if you're unsure about whether it's going to knock your print off the build plate, just print it with supports. The bit extra material doesn't cost that much. It doesn't add anything to your print time, and you're not going to be wasting an entire print for a print that doesn't come out. Yes, you can make a smaller hole inside with a 0.2mm offset. That is essentially manual support material. And actually on some more complex parts, I do that as well. Well, just add another separate unconnected part in here that I can just pop out afterwards and make for some very nice flush support material. Now this one down here might look a bit different from this one because it's not like this straight wall. It actually has this double edge down here. I think it should come out just as well, but there is going to be a difference in how these two print, if you directly compare one to the other. Okay, my perspective is gone. Let's reset that. Okay. Now, shoving this thing in your belt would work, but I just want to add a bit more to do a bit more, to get it a bit more professional looking and, smoother to wear and all that. So what I'm going to do is I'm going to go in here and do where we modify. I'm going to add a few fillets and chamfers, starting with the chamfer to make things easier to clip onto whatever surface you want to clip them onto. So right here and right here, just select the edges, tell it how much material it should remove, and we're just going to go with the hotkey, obviously. I should be using the numpad and not the buttons that are labeled with the hotkeys. Yeah, so right here, as we slide a belt in, that's going to make it a bit easier to slide in. We're also going to add a, where is it? There it is, modify fillet to the inside edges here, just to take that edge off. And I guess you can barely see it on stream, but it does select the edges that are a bit darker, and that's the ones it will end up chamfering. Is there enough material left from the zoom surface to the countersink face? Yes, this one, this thickness of material here is 3mm. That should be more than enough. We're going to have a look in the slicer how much material or how many walls we actually end up with, just to be safe. Now, I also want to add a bit of a pointy tip to this thing. Now, we could start out and add a, where's our modify? I keep getting confused in 1-2-3D design. We could just add a fillet to this and that edge. However, let's just try that. However, what that will create is a zero angle overhang down here. So the same as on the holes up top, but this one is like really close to the bed surface, and with a heated bed, this part right here is typically going to look very, very badly if you don't use support material. So, you know, whenever you have a part touching the build plate, typically you don't want to use fillets like that. You do want to use a chamfer first, because that's going to give you a 45-degree overhang and a much better print result in the end. So we're going to do that again. We're going to do a chamfer on this and on this edge. Let's do, how much? 8 millimeters or so. And then same thing as on the inside, we're also going to add a fillet right here. Right there. Fillet on these edges, on this and this edge. Because this thing is going to be poking against my skin sometimes. And it would of course be nicer to have this thing a bit smoother. Now what we could also do is to add a bit of a fillet to this edge right here, but since this is going to be aligned to the layers, this is going to have a 0.25 millimeter radius, so basically the nozzle diameter. That's going to be it anyway, so it's not going to be that sharp, and if push comes to shove, I'm just going to take a file and take this one down a bit. Okay, so there is our finished part. For those of you who just joined in, this is a belt clip for my Zoom H4n recorder. And yeah, super simple design. Now, if I did this in a real CAD tool, it would be a lot faster. Also, I typically wouldn't have people watching me, so yeah, that's it. Now, Autodesk 123D Design does give you an option to 3D print directly. And that's going to take you to Mesh Mixer. It's going to take you to Mesh Mixer, which is what I don't want to use right now. I just want to go the traditional route of exporting it to an STL, then having a look at it, how well it actually exported, and then send it to a 3D printer. So STL, we're going to see a few different settings. Fine is probably going to be fine. Yeah, medium. Slices a bit faster, whatever. It doesn't make that much of a difference. We're just going to save that to the desktop for now to find it. We'll call it H4n build clip. And there we go. Now, Mesh Milkshare. Yeah, talking is hard today. So, we've got our file done. Now, every CAD tool, every tool that you can create 3D files with is going to behave differently when exporting that from its native workspace, basically what you just saw on screen, to a STL file, which is, you know, just a bunch of triangles. And I'm going to show you that in a second. So unless I'm sure that my CAD tool actually exports files properly, I always want to go into a repair tool like Netfab and have a look at the file and see how well it turned out, basically. So we've got our H4n belt clip. Well, we could open it up with the Windows 10 3D view, and theoretically, but I don't know how far Joe is on that, but theoretically we should be able to print on the MK2 with... Why did all my windows go bye-bye? There we go. Theoretically, I should be able to print on the MK2 through Microsoft 10 or Microsoft Windows 10's 3D printing driver, which would be pretty darn cool, to be honest. Okay, but like I said, I didn't prepare for that, so I'll try to use the traditional route. So there's 3D Builder, there's our preview. Now, older Windows versions don't have that sort of a 3D preview. It's kind of cool to preview things, but I don't think it's really useful for a whole lot of stuff. So instead, we shall open this with Netfab. Good job creating shortcuts for yourself. Instead, we're going to try to open it up with Netfab. Netfab Basic is a free, is a free but non-open source 3D file fixer. I don't know how to describe it, but it's basically a preprocessor. There we go. I think the very original Ultimakers actually came with NetFab as a slicer. NetFab does have a slicer module, but it's different from what you're getting in Cura, Slick 3R, Simplified 3D. I believe that is that's my keyboard. Hello. And that's a hotkey in NetFab apparently too. Okay, but what we're going to be using NetFab for is just as a pre-processor, just to look at how well our files turned out and how well we are going to be printing. I still use 5.2. Dude, I might have just downloaded that. I don't know. I don't use that laptop that often for regular use. So yeah, first look in NetFab. It's all green. There's nothing that looks out of place. Typically, if there are some severe errors, it's going to show you like a triangle down here. But for now, it's like, yeah, it's looking good. But because I want to show you some stuff, how it would look if it's not that nice, I'm actually going to manually mess it up. So we can go into the repair mode and repair this thing. So we can take out some vertices right there. Make a few holes over here and flip a few, and just give you a view of or what it would look like if there's like an issue with your part. So as you can see up here, we can actually see inside the part. We can see the inside of this surface. Just to explain STL a bit, STL is basically a surface model, a surface file. That only has a infinitely thin skin on the outside. Just saw, if you jump back in here, is all triangles. Every little surface bit is a single triangle. And those should line up in a perfect world to make a closed hull for that part. And that is going to be what what your slicer is going to see and detect. Now, because I did mess this up, like I said, we can see inside the part. NetFab marks the inside of a triangle as red and the outside as green. So this is, I believe, a hole where we move some stuff. Yes, we can see the inside edge there. And this one is a flipped triangle right here where the inside is showing towards the outside. So those are just some typical issues you're going to be seeing if you're exporting from... what is it? SketchUp? SketchUp. That's what it's called. Yeah, SketchUp is known for creating horrible 3D files. So don't use that as a modeler. Use something from 1 to 3D at least to save you some issues. Also, some professional CAD tools don't do a particularly good job at exporting files. So yeah, what you can do is you can take it into NetFab. It's free. You can also use the online service, which is also free, and just hit the medic button up here. Hit automatic repair, default, execute, and it's all better now. We've got these two green surfaces here, or vertices. We've got the surface all closed, and we're good. There we go. There's our perfect part again. We basically did nothing all this time. Yay. Yes, NetFab is just to verify the quality of your design. The repairs NetFab is going to apply are going to look very similar to what you see in like the auto repair functions of your slices. So what was it? One of these parts. Yeah. I can actually show you if I can find the correspond. That's the wrong side. Anyways, but I printed a Raspberry Pi case recently, and there's a time-lapse case that I showed some parts of in the Atom 3D stream. So this one has 4 holes down here, and in the opposing side for this thing, one of the holes had a bad surface in there, and what the print actually ended up coming out with was with one of the holes closed, so you'd actually have to drill it out. And that's something the automatic repair in Slick 3R or in Cura added by itself, but that's also something you would have seen if you took it into NetFab. So if you have parts of dubious quality or parts that you don't know how well they actually exported, take them into NetFab, have a look at them, and yeah, just verify how well that stuff goes. Let me just see if I can show you this on an actual part. My PC is not liking all this live streaming. There we go. What's with the hotkeys? So yeah, that's the part that I'm talking about. So like I'm saying, it's got some. Come on, zoom in. Yeah, first off, what we're seeing is I can't really zoom in any further, and that's because this part is microscopically big. Cura actually detects this part correctly. Slick3r does not. Neither does NetFab. So that's just a bad export from whatever CAD tool this was exported from. And we can also see some red areas in here. So first thing I'm going to do is I'm going to scale it up. This is typically something that happens if you export in inches instead of millimeters, or do some other crazy stuff like that. I think, yeah. So now we're up to a size of 196 millimeters. Let's scale that up and zoom out. There you go. Okay, that was the first issue right there. And then if we, I don't have a middle mouse button, which means I can't really pan. That sucks. But if you can see, this hole up here is all red, so there's some geometry errors right there. These are looking good. So basically what the part ended up looking like, yeah, is this. So as you can see, NetFab automatically closed this hole right down here, and that's how it printed. It closed with this, it printed with this hole right here closed, which made the part sort of questionable, of questionable use. Yeah, like that. See, it's gone. And that's why you want to always check your parts in NetFab first, unless you know it has exported well. Okay. Now we're done with NetFab. So we've got our, we don't want to save that. We've got our functional part. You could just export that from NetFab again. Or you could, yeah, of course, not save it if you didn't change anything. So there's our part, just to give you another look at it. What was the question there? What is that case for? The case was for a Raspberry Pi time-lapse rig, whatever, not my design, I just printed it. It's in the, if you're interested in that, it's in the description of the Atom 3D review. It's basically, it fits a Raspberry Pi and I think a power supply, and then the Raspberry cam on front. All right. Yeah, Slick3r. I don't know. Does it? It's called Slick3r. Yeah, it's a slicer, just like Cura. You got Slick3r, you got Cura, you got Simplify 3D. What's the problem? Yeah, so let's move on. So we've got our part. There it is. It is beautiful. It is ready to print. Now, if you don't have a 3D printer, you can also print this thing. You don't need to buy one of these. If you like only print every once in a while, you don't need to go out and spend between the 175 and what was that, 2,500? If you just want to try it out, if you like don't print that often, or if you have print jobs that just need to get done in a certain amount of time and you don't have the capacity to do it, you don't have to buy a 3D printer or buy a fleet of 3D printers. You can go out there and print it in on someone else's printers. So if you've got like little detailed parts that you want to print in metal, ceramics, better plastics, nylons that are stronger than what you're getting on an FDM machine and more detailed at times, you can go to Shapeways and have them printed for you. Or if you want the sort of quality of 3D hubs or of the FDM machines, you can also go on 3D hubs and have it printed there. And that's actually what I sort of want to show you to give you a reference of what sort of price tag is attached to this part. So 3D hubs also has more professional printers, but it's mostly built on having these FDM printers that we typically use available to the public. So I do have a 3D hub listed, just in case you're wondering, I have the MK2 listed on there. If you if you sort of want to try things out and want it printed by me, haha, there's a shameless plug for you. Desktop H4N belt clips. So let's just check out how much 3D hubs would charge, or the 3D hubs stores would charge. 3D Builder, that's just the default 3D print builder. That's on my Windows 10 Home, I think. 11190. Do I do free shipping? No. Okay, so we've got our part uploaded. It gives us the bounding box of how large it's going to come out. That looks about right. That's something to check. And also, if you export it in a different unit, you can check the different units there. And there are some hubs in my region. So Future Forge in Salzweg, I have no idea where that is, would print this part from €7.27 in general purpose plastics. Josef would print it at roughly $10. Lucas would print it at $6, plus whatever you want to pay for shipping. So yeah, pay $10 minimum for that clip. That is not up to me. That is not up for the customer to actually decide how much they want to pay, because every hub can have its own setup, cost and its own per volume cost. So typically 3D Hubs charges you can set up different pricing models. The way it's usually set up is you have a fixed fee for setup, just for your print. What's the name for that? The person that's running the 3D printer, your 3D printee. I don't know. For him to actually take your order, have a look at your files, check them again if they're printable, if they have any errors, if there's anything that's so wrong with them, if there's anything you need to improve, then to actually physically or go to the PC, slice the files, prepare the files, go to the 3D printer, clean that off, start the process, then pack it into a package, ship it to you. Every 3D Hub can do their own price structure, basically. I've set my hub up so that basically filament doesn't really cost that much and printing time doesn't cost that much. And instead, I want that time that it takes me to communicate with the customer, to communicate any errors he might have, to set up the printer. I want that valued, so I have my setup costs relatively high. But if someone comes in and wants like a huge print that fills the entire build volume and needs up 2 kilograms of plastics, that's not any more effort for me, so I'm not going to be charging that much more for it. Windows 10 3D Builder, while we're at that, Windows 10 3D Builder does support, theoretically, any board that runs Marlin. That's the way it's been advertised. I don't think it works that well yet. I'll have to look into that. All right. 12.5% 3D Hubs tax. That is. I asked them on Twitter, and they were like, if you run it down, it's only like 10%, because they do run like discounts and stuff that only 3D Hubs pays and not the seller or the hub. So it's they own the platform, as does eBay. eBay taxes are ridiculous, so you can get into that as much as you want. But we were talking about 3D printing, so let's move on with that. Now I could order from one of these hubs right here, and they typically have like different delivery dates. This one delivers by express in 5 days, including this Sunday. So typically that's going to be a few days. If you've got some of the lower end, if you put the widget on the side, it's lower. That's sweet. Thanks for the tip. So if where's my mouse cursor there? If you want it faster, it's probably going to be more expensive, but typically it's like a week until you get something from there. So since we don't want to hang around for a week, we're going to print it on our own printer. So obviously we've got the Prusa i3, the genuine Prusa i3 Mark II set up, and basically ready to go. We're going to quickly run through a few things. you should do before every print. Just, a few basic checks. And yeah, first let's start processing the file, because that's what what I usually say. That's where most of your print quality comes from and can disappear. So that would be the slicer. The original Prusa i3 Mark II comes with a pre-configured Slick3R install. If it would actually open up. Did I not double click this? Let's see. There we go. So it comes with a Slick3R install and a whole bunch of print profiles set up. Not every 3D printer has that. In fact, the only other 3D printer that I've seen this sort of a sophisticated and specced out slicer profiles are the genuine Mark II. The Lulzbot machines, the Mini that's back here, as well as the TAS 6 I tested, those have a very, very custom Cura version that's delivered with them, as well as the Ultimakers. Because of course Cura is Ultimaker software, so it does have all those profiles for their printers already in there. Do we use Simplify 3D? I do have a Simplify 3D license that I got from the Simplify 3D guys when they released their, I don't know which one the newest one was, but I haven't really used it yet. I haven't seen the need to use it yet, but I will look into that. I like both Slick3R and Cura. I've recently taken a big liking towards Cura, but that's mostly because the Slick3R build is so rarely updated. The version Prusa supplies is actually a much more recent version than what you can officially download from the official Slick3R downloads. So that has a whole lot of bug fixes that I felt like kept Slick3R back. Especially, what's annoying me the most is well, you can sort of see that. I guess that is still in that version of Slick3R, but I'm already committed to that. So what you're often going to see Slick3R do, some versions less than others, is these imperfections on sloped surfaces where it doesn't feed enough material behind the top surface, and then has the upper layers droop in. So that's something that Slick3R often shows, and in my experience, Cura is just much better at hiding. Will the Prusa slicer run a Delta? Yes, the Prusa build of Slick3R will actually run any 3D printer. It's not constrained to the original machines. You can configure any other printer with it as well, and you can also get unofficial Slick3R builds. If you check out the Google Plus 3D printing community, there is a discussion, I think like on page 2 or 3, where you'll find the unofficial Slick3R builds for Windows, Mac OS, Linux that are built as a nightly, so from the very quickest sources. Most recent sources, words, they are hard. Okay, Slick3R. There we go. Cura is good for models with support. Yes, so is Slicer or Slick3R. They all sort of work these days. That's actually, the slices have come a long way, and I do appreciate how much effort is being put into them on a monthly and weekly basis. We had it open already. There we go. Okay, so Slick3R. Let's grab that file and pull it right in here. So because we took care to properly orient the because we took care to properly orient the file in Simplify 3D already. I wish I had a middle mouse button. Okay. Because we oriented the file in Simplify 3D correctly already, it's already like sitting with the right side towards the build plane. So the plane down here is of course going to be your build plane. And we can see the overhang is oriented correctly there. Now, because I want to save some time, yeah, because we want to save some time on this print, we don't want to drag out the stream unnecessarily long. We're going to go with the fast profile, 0.35 millimeter layers. I might tune that down to 0.3. We've got the PLA configured profile, so Slick Through is kind of good in that way because it has your print settings, which determines your print quality and a lot of how details come out, and then it's got the filament profile separate from that, as well as the printer profile. I don't think the separate printer profile makes that much of a difference because you're not going to be using, well, you're often not going to be using the same print settings for a different machine. You're always going to tune that to the machine typically. Yeah, the fact that you can use different filaments with the same print settings without having to use like completely different profiles, then words. Yes. Yeah, that's a good feature. It's better than having that single monolithic design that's in Cura. So, so right now we've already got a sliced part right here. We can switch over to the preview, and what we can already see is we have two shells on the outside and then infill in here. And let's tilt it a bit so you can see that better. So that's what the part is going to be looking inside, and right here we have, let's just take a look at this first. So what I typically like to do to like evaluate how well an overhang is going to come out is to take a look at how much each layer differs from the last. So that's, if you look at the difference from that to that, that is like half an extrusion width. That is going to come out borderline okay. Right here, we've already got like almost a full extrusion width. So that is definitely going to sag, as well as this one. This one is like all in the air already. So that's going to be a part that doesn't look that nice, but I think it's going to be okay because the very next layer is going to be the bridge, and that one should come out pretty okay to actually fill up this gap and to take care of whatever curled up here or dropped down. And yeah, it's not a functional corner anyway, so we should be okay. Also, if you can notice it, the Slick Through built by Prusa has anti-aliasing enabled by default, so you're not going to get those crazy moire artifacts there. Right. Well, except for these, obviously. So that looks kind of okay, but I do want to use a different. I do want to use a different infill for this, and I might also want to use a thicker wall thickness because this part up here especially is going to see a lot of bending stress and bending forces. So let's just jump over here into print settings. So layer height, like I said, I'm going to take that down to 0.3. Perimeters 2, there we go. So let's bump that up to 3 and let's have a look at how that looks. Yeah, and how it looks compared to the old one. So that might actually be, so what do we want to avoid? Let's bump it up to 1 more and see what happens. What we want to avoid is the print only being what we want to avoid is the print only ending up with perimeters, basically. So like this part right here, that is usually a bad thing to have because these inner perimeters that you see right here, that is not going to give you the strongest part. Sure, Slick Through, the newer Slick Through builds take care of the rougher artifacts where it just wouldn't fill in the very center here. But I know some older Cura and Slick Through builds will actually have a void in here that's not filled by perimeters or infill or anything else. So right right now this one looks okay, but what I typically like to do is bump it down to 1 parameter less and then increase the infill density. Right, but you know what, let's just take it down to 2 and see what the infill does. So by default it's set to grid, which is a very primitive way of handling infill. I'm going to pump that over to 3D honeycomb actually and set it to 20. 3D honeycomb is a very slow it's a very slow printing infill, but it's gonna look cool, so that's okay. We don't need anything like brim or a skirt. Well, the skirt is configured by default. We're also not going to need support material. We could try adding it, but I don't think we're going to need it. One more thing to check is temperature, 210 and 55, that looks good. So right now the print should be... Oh wow, I might change that infill. I'm definitely going to change that infill. Okay, so I was expecting a bit of a nicer infill from the 3D honeycomb. Let's just bump that back to grid and yeah, that should turn out nicest. So on the topic of 3D printer, yeah, just on the topic of 3D printer safety, I've actually had a few mainboards emit some smoke. Let's put it that way. Especially things like screw clamps. I don't know if I have a... let's just take that other orange 3D printer. So things like these screw clamps right here. These are rated for like 8 amps, I believe, or so. And many manufacturers use them for like 15, 20 amp inputs. And while they originally work fine, it's not going to hold up. Also, things like tinned wires in these clamps is a complete cardinal sin. But generally, if you build your 3D printer, well, if you use the right gauge wire, if you use genuine boards, if you use genuine components as far as the critical parts, main board, like I said, hot end bed heater, that sort of stuff. As long as you use good parts there's not much that can go wrong. If you and of course configure your firmware to include the safety features, which some manufacturers just disable to make their printer work, which is why I typically go into such detail when it comes to what sort of a board a 3D printer manufacturer uses for their machines. Okay. I didn't do a Delta tuning guide yet, because I never had to do it. The Cerberus Reborn, which is off frame over there, that one was auto-tuned with Smoothie, and the Atom came tuned out of the box, never had to do it, so I don't really know that much about it. Yeah. Right, so let's head back in here. So the other thing I want to have a quick look at is the overhang down here. So like we checked up here, we actually bumped down the layer height to 0.3 millimeters, 300 micron. So the difference between each layer is a bit less than it was before. So this overhang should print a bit nicer. Let's have a look at this overhang down here. And that one does look very nice and very nicely staggered. So that one should come out pretty much perfectly as well. All right. There we go. So there's our sliced files. I mean, SlickThread does give us the 2D preview as well. We sort of don't need that because we have the 3D. Now we have... Where's my camera? There's my camera. So, like I said before, we have a few different options to get that file those basically, you know, basically what your 3D printer is going to see of the part is this exact thing. Well, actually more like this. It's going to get individual moves. It's going to get move from A to B, then move from A to B, move 10 little steps, keep the temperature at this level for a given time, and then, you know, raise the nozzle, go up in the Z direction a bit, and then do the same thing over again. And that is what your 3D printer sees. It's not seeing the part. It's not seeing you know, any of the details you put into designing the part. It's not going to see whether it's an organic or a mechanical shape like we have here. It's only getting those tiny little moves plus the commands for heat up, cool down, do an auto bed probe, and those sort of things. It does not know anything about the model. So that is why I think the slicer has an enormous that's sort of an enormous influence on what your part is going to look like, how it will print, because everything is basically set in stone after that. The few things you can still tune on your 3D printer if you have an LCD display or, you know, control it through USB. You can tune the speed at which you're printing. You can tune the feed rate basically to say go faster, go slower. You can tune the extrusion rate. So say you have a different material in there that has a different diameter, so you're over extruding or under extruding. And you can also tune what temperatures you're running your heated bed and the hot end at, and that's it. That's basically it. So everything else you will need to have set in your slicer correctly. So yeah, the three options. Is it three? Yeah, I guess let's say 4, 3. Let's get into that last one that might be 3.5 in a second. So the main options we have for 3D printing something, and the options that are mostly used are using USB. This guy has a USB port right here, which we can just plug into any computer, even the Raspberry Pi works, any Windows, Mac, Linux computer. It's going to show up as a serial port, and we can connect to it with Cura itself. Cura has a host in it, or Pronterface, or any other specifically made 3D printing host. Pros and cons. Well, pros, you have a very direct control. At least I feel it's a very direct way of controlling stuff because is it really live though? Yes, it is. It is the livest I've ever been. Let's just see. Let's just open up. Where are we? Pronterface. Come on. Pronterface. There we go. Yeah, it's all pre-recorded. Pronterface. So what you're getting is basically a preview of your file, basically the same you've got on you just saw in Slick3R, and you get controls before you start a print. Once you start a print, those won't actually do anything because they get overridden by your G code immediately. So you got those same sort of controls. You got the temperature right there. You got the bed temperature. And what I like most as a power user is you're getting a console, which means you get all the power user functions right at your fingertips. However, the way the USB based or PC based, the way the PC based printer hubs have to work is they have to send out G code to your board, and there are buffers, both in the serial stack. So even before the processor sees those commands, they're buffered. Then there's another buffer in your in the firmware that runs on the printer. So everything you send is always delayed. So there is like no instant immediate feedback while the print is running. So say you have very long straight moves, those take an enormous while to complete, but don't take up a whole lot of that buffer space. So it's going to have a whole lot of those long moves buffered before you can actually before it can actually influence your print in any meaningful way. The LCD does sort of suffer from that as well, but is a bit quicker. The other problem is, of course, if you have a laptop that runs your 3D printer, as soon as that laptop runs into anything, most importantly, Windows 10 updates, which you can now not disable anymore, or you cannot disable the automatic reboot. I don't know why they did that. As soon as your PC gets an update, reboots, your printer is gone. The printer just stalls and stays there. It's going to have the heated bed going. It's going to have the hot end heating. It's still going to maintain its temperature. It's not going to burn down, but it's just going to stall and stop there, and there's nothing you can do to recover it. Basically nothing. So that is like the one biggest issue I have with printing through USB. I used to print a whole lot through USB, but now that I don't know, Microsoft, why you do this to me? Yeah, now that they're doing that, it's not really attractive anymore. Plus, of course, you do have to sacrifice an entire laptop or desktop PC, or like you said in the beginning, like a Pentium 3, some old machine, and set that up next to your 3D printer. It's good to have as a slicing machine and as a printing machine at the same time, but yeah, not recommended. Not recommended to use a Windows laptop, at least. No, you can. Well, so Windows 10. Windows 10 before the anniversary update used to have an option to disable the automatic reboot after the automatic updates. Now it does not have that option anymore. So if it does an auto update, it will reboot afterwards. There's nothing you can do to stop it. You can still disable Windows updates if you're on a Pro version. However, you don't really want to use a Windows device with automatic updates disabled. That is pretty idiotic. Daniel Conrad, thank you for the tip. Let's just say, by the way, yes, we still have stream tips set up. Wenn du weißt, wo Spritzen und weiß, wie deiner Wahl, Spitzenjob, mach weiter so. Thank you, Daniel, for the tip. We have stream tips set up if you want to see your tip on stream live as a big ass overlay and send a message to. You can do that. Always appreciate it. Yeah, so Windows 10 not recommended. Octoprint, yes, Octoprint, the other option, using a dedicated host, so either a Raspberry Pi or proprietary hardware like the Elements that we tried out in last weekend? I think so. In last weekend's stream, very simple, similar concept to Octoprint, basically a simple, just grab the Pi. Yeah, basically a simple one-board computer that runs a Linux system that has USB, and this part right here works exactly like your laptop, like a printer host. But of course you get the advantage of having a specialized interface available on the network and having that small dedicated device and not having to use a full laptop or desktop PC to run your printer. So that's the other option. That is something I like a lot too, because you don't, like I said, you can print from anywhere inside your home. You can connect it to Ethernet. If you set it up right, you can even slice on this. So you just send it your STL, what we have there, and you can basically fire and forget. You can connect the webcam to this. So put a webcam there, monitor your print from afar, and off you go. It's a bit of work to set up. I did make a video about that. It's not complicated. It just takes a minute to do. But once you've got that set up, it's all working and running. Gina is doing an amazing job of maintaining Octoprint. So if you have a Raspberry Pi sitting around not knowing what to do with it, maybe try that. It's a good use for it. And then, of course, the where can I find the files needed for Raspberry Pi to work with 3D printing? Look on my YouTube channel. Look at or search for Octoprint, and there should be a 2016 version Octoprint video in there. All the files are linked in that description. Yeah. All right. So, last option, SD cards. Well, sort of. Well, let's get that half option out of the way too. Some printers come with a network interface built in. So something similar to or functionally similar to Octoprint. The D3D1 Pro has has a Wi-Fi interface built in, so you connect it to your home Wi-Fi and then send it the finished sliced files. The Smoothie board, which runs which is soon going to run both of my Delta 3D printers, but right now runs the Cerberus Reborn, also has an Ethernet jack, so you can send it G-code files and control it from there. That's like a half solution. It doesn't do as much as Octoprint does, but it still does that job of printing without a host and printing without any extra hardware. So the printer itself handles all that, plus gives you the Ethernet interface. Now most or many 3D printers now come with an SD card slot and an LCD display. So that's very similar to what I just said the One Pro and the Smoothie board do. They have an integrated way of reading G-code files, and so does the MK2. In this case, it's through an SD card file. You just pop it in the side here. There we go. Just pop it in the side and then control it through the LCD screen and the push knob. And slightly out of focus. It might be focused up here. I might be slightly out of focus. Yes. So yeah, that's what I've been using mostly recently. Just because I don't have an Octopi setup. I don't have Octopi set up on any Raspberry Pi. I should do that, and then I will be back to using Octoprint. But for now, for the simplest version and most reliable plus most performant version of 3D printing would be through an SD card. Plus bonus benefit from when it comes to performance. Bonus benefit for my eyes are out of focus today. I should refocus that camera. Yeah. Bonus benefit for the SD card is the Arduino can actually read from an SD card slightly faster than it can receive commands through USB. So what you're going to see on highly detailed parts, like the title image of this stream, the Thayer Gakstatter Dizzingoff. It's in the stream description. The Dizzingoff designs are very high polygon, so it's very very short, very small moves for each little bit of your design. In fact, let me pull one up in NetFab real quick. Thanks to Dizzingoff for sending me some of his designs, by the way. Those are awesome. Let's just see. Let's pull up that exact part we were talking about. All right, let's head into repair mode because we can see the vertices there. And you can see this one was processed to sort of strip out the vertices, but in here there's a relatively fine and dense mesh. So this one is actually still okay. This one should work through USB or through SD card. But still, it's a rather high polygon model. And through USB, the printer might slow down in these little regions down here where it has to do these little tiny moves. Every single triangle is going to be an individual G-code command. So it's going to tell the printer to go from here to there, then from here to there, then from... If you can even see the mouse cursor moving there. So that's an extremely high detailed model. And that's something where an SD card would definitely help. And yeah, in fact, that is what we are going to do right now. So we have, where's our slick through? There it is. We've got the SD card. Let's hope it doesn't break anything Windows-wise as I plug this thing in. It's interesting how the H4n always assumes like the default output device. That sounds so strange. Yeah, so basically what we want to do, export G-code. Save that to the bunch of stuff on there. I think that's still the default. Yeah, that's still the default files from the Prusa MK2. So let's head back here. That's what you want to see. Build clip, G-code, save. By the way, I'm not missing your tips. I might be a few minutes behind. Thank you, Peter Korst, the Killer Bee, and Spike Kent. This is a random note, yes, and great stream as always. So thanks for your tips. They make buying food for me much easier. Just kidding. But I will have a cold one on you guys. Thanks a lot for that. Yeah, so we've got the... let's just double check again here. So we've got the file saved on the SD card. You always want to make sure to properly, safely eject that. And that's ejected. That sounds so weird. You know what would be cool if this would actually physically eject the SD card out of your SD slot. That would be a feature why I would buy a new laptop. You know, just have the SD card go poof when you hit that eject button. That would be very, very nice. If anyone knows a solution like that, let me know. All right, printing time. Now, there are a few things that you want to check before every print. So basically, like a pre-flight checklist. I mean, once you get to know your 3D printer, you will have a feeling for what will work, what will work, what won't work. But there are a few generic things that you should look out for. By the way, question in chat: printer for a college student that has less than $800. This one is less than $800, and it's the best goddamn printer I've ever used. So that's it. And it's you know, at that price it comes with a kit, so you do learn about the printer while you go. Flying SD card. Flying SD card? Paul, so here is thanks for the tip. Let me just refresh that and see if there's a message attached to that. No message. And Kurzschluss 84 Volt, viele Grüße aus Österreich. Thanks for that. Yeah. All right. To get the SD to the printer. Expendable quadcopter frame to just fly that over. That would be nice. Softer materials. Soft, like I've got a few soft materials. I'm going to show you those when the print is going. So let's get into that first. And actually, let me. Headphone users, you might want to take your headphones off for a second. Okay, got that rotated. Okay, pre-flight checklist. Okay, what you want to check, of course, is you want to have some filament loaded. Obviously, we've got there's some Prusa own brand, no name, gray. I've also got a bunch of other ones. You want to have that loaded. Every printer manufacturer is going to tell you a different way how you're going to be officially perfectly loading your filament. So that's up to the printer manufacturer to tell you. Typically, I like to heat up the hot end first and then manually insert it. I don't really like those routines. I like to feel how I push in my filament. Then, one thing, okay, you should push the stepper motors by hand. Anyways, but one thing you sort of want to check is right over here you can see into the hop section of the hop bolt. You want to make sure that there's no shavings, no leftovers from the last print that might have gone wrong in there that might impede your 3D printer's performance by influencing how well the extruder feeds. Next up, obviously preparation of the bed. And this is all stuff before you turn on the 3D printer. Preparation of the bed. You want to make sure your bed is clear. You want to make sure, especially those little boogers, like the MK2 primes, its extruder right here. You want to make sure that is gone. And you also want to make sure that the rest of the bed surface is smooth. There are no defects in there. So this one uses a PEI. The microphone's over there, right? This one uses a PEI bed coating, so it's an extra sheet of material on top of the heated bed. Other printers use a plain glass sheet, of course. You want to make sure that's not damaged. And on either one, unless you're using something like glue stick, which is more of a forgiving coating, glue stick or something like 3D-Ease or Magigu or any of the sprays or lacquers that you put on before every print, you want to make sure you wipe it down with some sort of a cleaning agent, with some sort of a solvent. I like to use alcohol or ethanol, basically denatured ethanol. Just put some on some professional cleaning rags, wipe that stuff down, and make sure any grease you got on there from your fingers or from somewhere else is just wiped off. It doesn't matter if you see some streaks on there. We're not cleaning the window here. We're just preparing a build plate. And of course, if you use an unheated bed with blue tape or something on there, you can wipe it down. That can modify how well your prints stick. 1 second. But typically, blue tape surfaces are generally perform worse than unheated specific surfaces, but are more robust, as in, how much you can do wrong with them before they don't work anymore. You get some grease on this one and your print is going to come loose, so just wipe that down and make sure that is clean. Did I miss anything in chat? Okay, I get that. Okay, so pre-flight, yes, that should be it. And of course, if you've been using your 3D printer extensively and not taking care of it, it might be a good thing to just check that the rods are clean, that there's no dust on there, no grime buildup. If you've got now this one is using the LM80U cage bearings, so they have seals on the ends. It's a good idea to eventually oil those or put some grease on there. Same on the bed. Make sure your belts are tight, or at least tight enough. You don't want them flopping around. In this case, these are super good, so they're going to give us good clean prints. Yeah, and that is pretty much it. So that's just something you can check with one quick roundhouse kick, basically. Take a look at your 3D printer, make sure it's in good working condition, and one more thing: unless you have the cables routed and supported like this down here, make sure that there's nothing out of the ordinary, no cables hanging around, because that can be a very, very quick and eventful, in that case, end to 3D printing experience for that day. Yeah. There's a hairspray brand in Spain that adheres so well to plastic. Yes, that is. I don't know if you're talking about 3D Lac or if you're talking about just a generic brand, but that stuff actually heats up extremely well, or that sticks extremely well. PLA sticks to a cold bed too, and it's pretty hard to remove. I prefer having a heated bed because once stuff cools down, it just comes loose. Whether it's glass or PEI, it's just more comfortable like that. All right. Let's turn it on. Do you hear that? I don't hear it. I like it when a 3D printer is actually quiet when you turn it on. I've had some that just start screaming with their stepper motors all over the place. So yeah. I'd like to try Magigu. Yes, they are. I don't know if I can talk about that, but they are improving their product. They're sending me a new one. I just threw out the old bottle because it started leaking all over the place. So let's see if that new design does anything for me. Okay, it is quiet. It is operational now. So we wiped it down. We checked that the extruder is clear. We checked that the filament is loaded. Now on lesser printers, you might want to check. If you didn't check it for a while, or if you moved the printer around, you want to check that your bed is level and properly oriented. The MK2 is going to do a quick auto. I don't want to say leveling because leveling is technically wrong. You don't want to get it into level per se. You just want to make it perpendicular to the rest of the machine, and that is exactly what the sensor on the MK2 does. And on most of my other printers, Not that one and not that one, but all the other printers have some sort of an auto leveling system, and where it will make sure the bed is actually properly aligned and doesn't print in the air on one corner and smash it into the bed on the other. So we're gonna head in and go. So this is it. There's nothing else to do. Most important thing again is to clean the bed to get good adhesion. And we are going to say no SD card. Okay, we actually have to plug that in. Some 3D, yes, the MK2's power splitters have no fan, so that is silent. It does get a bit warm, but not excessively warm that it would burn yourself. Some 3D printers don't like it when you plug in the SD card while it's running, so you would have to actually hard reset it. This one does work. So we're gonna say print from SD. We've got the H4n belt clip. Some printers have like a print newest file option or anything. Just move that right here. And we're gonna start it. So because we use the official Slick 3R because we have used the official Slick 3R install on for slicing everything, it has the custom G code in here that actually does everything from heating up the bed first, then waiting for the hot end to get the temperature, then doing the bed leveling we just talked about, priming the extruder. Some 3D printers do have did I just say extruders? Some 3D printers do have you manually priming the nozzle or do some of those things. This one has it all integrated. It just, again, it's just going to depend on your exact 3D printer. But typically in the long run, you want to have it set up like this, where it just does everything automatically before you print. Yeah, so the way it's Slick 3R, it's got the D3 in there. So that's a 3, it's not an E, it's a 3. Yeah. What was I going to say? Multi-extruders. How do multi-extruders work in software? Basically, it's all still the same G-code. It's still the same commands. Go from A to B and extrude this amount of filament on the way. But there is a switch code in there. So it tells the printer, okay, from now on, you're going to be using extruder 1. And every command I tell you is going to refer to that extruder 1. And from now on, you're going to switch back to extruder 0. And basically, that is how dual extrusion is handled in any software, in any firmware slicer right now. It just has a point where it says, okay, from now on, any extruder moves, because this is essentially a fourth axis. This is a linear axis along the filament. Every move I tell you from now on out is going to refer to that other extruder. Stream frozen? Nah. Is where guys is the stream? I don't not my problem, guys. Not my problem. Yeah. Also, one more thing you might want to do before a print is to make sure the nozzle is clean. I did miss that. It was clean before, but there we go. But from heating up, it did, just this little booger right here, it did ooze out a bit of filament, which, this priming path right here takes care of. Also the skirt that it's doing before a print, where it just prints one basic loop around the part before it starts in the actual part. That also takes care of some of these boogers that might be stuck to the hot end or might come out as you're printing. So, yeah. Ich build into which one do we answer? Yes, okay, print time estimate, because that's something that I'm interested in as well. So Slick 3R does not have a build time estimate integrated, so it only gives you, well, actually it doesn't give you anything. If you head into the 3D view, you can click the thing and it gives you like a volume estimate and stuff, but it doesn't give you an exact time like Cura does, or anything useful like that. So what we're going to do is we are going to head over, we're just going to save this thing, desktop save. So now we have the G code that we also have on the SD card, and we are going to head over to gcode.ws. You're bored? Oh, let's turn that on. Let's turn that off. Where's my webcam? Nope. That's the button. Okay. There's the printer working, so you can have that going. I'm gonna get the camera a bit closer in a second. So what you can do on gcode.ws is you can upload your finished sliced G-code, and it's going to give you very, very similar results to what Cura is telling you. And I don't know what the current state is, but it used to be like very similar to what Octoprint used in the G-code preview estimate thing. Audio out of sync? No. Nothing changed for me, nothing changed on my side. My internet connection is super stable. I've got the 10 Mbit up, 50 Mbit down. Not a problem on my side. If your stream is freezing, audio unsyncing, it's just that YouTube Live is still like in its infancy. YouTube Live is still a super, super large mess. Yeah. So gcode.ws. If you're using a slicer that doesn't give you the estimates like Cura does, or I think Simplify 3D also gives you those estimates or of how long your print is going to take and how much material it is going to eat up, gcode.ws does that for you. So it's got an estimated print time of 43 minutes and 34 seconds. And as far as I know, that also does take into account like linear accelerations, because it's not, if a move is specified at say 60 millimeters a second, it's not going to do that move instantly at 60 millimeters a second. It's going to first ramp up its speed and go at full speed for a bit and then slow down again, especially if it has to do those tight infill back and forth moves. So this is a realistic guesstimate, basically, as good as it's going to get. 43 minutes, I think that's pretty good. So next up, time cost, filament cost, using defaults. The interesting one is 14.11 grams of filament used. That is typically super spot on accurate. So yeah, there's that. There's gcode.ws for you. 2D preview, basically the same we saw in Slicktheory already, and we also get a 3D file or a 3D preview, but that's like barely usable, I feel, because you're not really seeing any extrusions. And you're also seeing that the G-code, if you really want to dig into that, G-code is human readable, G1, go to this position, go to XY, this position XY on the bed, and extrude this amount, or that's okay, extrude this amount of filament along the way. So very, very simple command. It's just a bunch of those that make up the eventual finished 3D print. Yep, Joe, thanks for the mod, helping out a lot there. Right. SLA versus FDM. Well, SLA is always going to be more expensive than FDM. That's just something that's I don't think is going to change ever, because resins. Just look at how much epoxy resin costs versus buying a block of plastic. So yeah, SLA is always going to have that price disadvantage, and FDM, as many limitations as it has, is already in a very good spot, because it does do a whole lot already, and it's only getting better. That's a good thing. G code, just Gerber code. I have no idea what it stands for, to be honest. I have absolutely no idea. So what I'm going to do is I'm going to grab this camera up here and I'm going to move it into the print so you guys can see it printing. You guys can see it working. It's magic. And I'm going to give this camera a new battery in a second. Oh, sorry. By the way, if you're wondering how I'm getting those smooth time lapses, I guess I should switch I should switch over here. In case you guys are wondering about how I'm getting those smooth time lapses, that's it. Slider, a bit of a not a counterweight, but a flywheel basically. Arduino, stepper motor, stepper driver. That's how I roll. Oh, and of course I built that. Where should we put the camera? I might actually run out of USB cabling, but we're just gonna have to try it. Print? We are printing. You want to see the print? Ah, okay. I'm working on it. Relax. That's that. Let's see how many things we crash while we try to set this up. Oh wow, that might be a really close call. I still love how you kind of can't hear the printer, how the MK2 is really basically silent except for its fan. Let's put this guy in again. Yes. Okay. Now we got the print set up. As you can tell, there is another camera right there. Let's head over to that. One second. I think I need to flip this one. There we go. That's looking better. And let's turn on the V-cam as well, so I'm not completely out of the picture. Yeah, Meta. You guys are asking about the slider. I'm just going to use the little camera in the slider. So we've got. Let's give it a battery. So everything run off of Sony NPF batteries. That just plugs in down here. Most of you are going to be watching the print, but that's okay. Sony NPF battery, touchscreen right here, so we can change the direction right there, left or right. Still need to make like a little knob here, and this one basically, there we go, gives you an like an estimate of how long the entire length will run, and then how fast it's going, and you can basically just click. Let's grab the camera carriage over here. Yep. Just click that thing and it starts going, and you can tweak it in real time. There you go. Yep, that's what I use, and you know, you can set it for days or weeks if you want. But for now, let's get back to 3D printing. Yes, if you, I should focus. If you like in the stream, I'd appreciate a like, and if you want to see more of what I'm doing, of course, there's always the option to subscribe. That would be very much appreciated. Yes, Nightbot is actually helping me out there. So I said, my browser is not happy. What's the purpose on the flywheel? It was there while I was using it without the Arduino control. It was making the motion a bit smoother. But now that I have the stepper motor on there and actually control through Arduino, I could actually take it off. MK2 does print upside down. It's nah. Um, 60 FPS 4K is not an option yet. Cameras don't even do 60 FPS 4K. Alright, the stream will go live, as a recording, as always, because this is supposed to be like a, if we find an uninitiated 3D printer, someone who's interested in 3D printing, just as a reference as what these steps are, what you should be expecting if you want to get into 3D printing. Is the Element stream up on YouTube? Yes, it is. You can watch the full recording. You can watch the full recording on my regular channel. Would I suggest the Prusa full review coming in this week? That's unless you want to do unless you want to scroll back on this stream. You're just gonna have to wait for the full review. Low is it low FPS? It shouldn't be low FPS. Okay. Hold on. It shouldn't be low FPS, but I might be able to change that. Oh, it might have been auto exposure. I'm sorry. Camera didn't want to bump the ISO up, so I will have to bump that up manually, because this is the stock lens, which isn't a great lens, but it's a lens I have. Whoa! Focus. That should be in focus. Okay. Now I'm seeing low FPS. What? One second. Let's deactivate this and reactivate this, and it should be streaming. That's the problem with these cheap other media capture things. They do sometimes bug out and give you like super choppy low FPS, whatever. Thanks for that tip. These are not GH4s. I can't afford GH4s. These are Panasonic G7s. One here, one over there, recording the main image. They're pretty much the best camera I can, the best camera I know of. They're awesome. Right. Let's get back into 3D printing. with a yes, I'm fine. I bumped into the tripod. We're all good here. So a small question about well, let's do this one first. Race 3 N2 Plus. Possible to get a review? Yes. I just need the machine. That's all. I think I've talked to the guy before. Not sure, but sure. If I get the machine somehow, I can do a review of it. Because we were sort of doing, yes, this is this light back here. This is the bed heating, just an indicator of whether the bed is heating at the moment or not. Prusha is running out of anxiety pills. You will not be disappointed. Yeah. So on the topic of open source hardware, because I just saw Open Source Hardware Association somewhere. This machine is as open source as it gets, basically. Well, almost. I don't know, Joe. How much are you putting into community? My frame of reference is basically Loadspot. Loadspot are like super insanely open source pro. You know, they're editing everything on Linux on completely free Libre open source software. They're publishing everything under super non-restrictive licenses. They're supporting the open source community. In fact, they're even sponsoring me through Patreon, which is why you're seeing that one sponsor spot a month after a video. They're supporting Gino Heusker and Octoprint. They're like all out. This one is like totally. Even the firmware is open source. Yes, the firmware is like the least critical part of those, because the firmware is done by the community. That is something you always have to keep in mind. 3D printing has always been, or at least the RepRap revolution we've been seeing recently, has been driven by the community, by mostly individuals, I guess, going out there and saying, okay, I'm going to put my heart and soul into this project. I'm going to make this the best firmware out there. I'm going to make this the best slicer out there, or I'm going to improve or build something new because I'm not happy with the stuff we had out there. Now the i3 is, of course, you know, you could also call it the gold standard of open source because everyone's copying it. That's, I guess that's, yeah, as good of an endorsement you can get. It is, of course, the i3 is the genuine i3 is open source. You can get all the 3D printed files. You can get the improved modeling firmware. In fact, I think a large part of the changes are already being migrated into the main branch of Marlin, so everyone else gets to use them as well. Also, you know, just having the design open source is already a huge step. I do prefer having you know, machines that do publish the design files, just because not because it really matters, as in I'm gonna build one myself and, you know, print and source all the files. No, because it matters to me because I can go in and modify them, and I can just grab the source file for any of these components on here, make a small modification, reprint it without having to like reverse engineer the entire part. And that's why I care about, for very, very personal reasons, obviously, why I care about open source. So yeah, open source is kind of important. If you got the choice between an open source machine and someone who's not publishing anything or not giving anything back, I would seriously urge you to go with the free Libre open source machine, just because it's better for everyone, to be honest. Yeah, so chat. This is the Prusa, the original Prusa i3 MK2. There's a difference to the Chinese clones. Many of the Chinese machines that you're going to see marketed as Prusa i3 or Prusa i4 or whatever else i3, they have very little to do with this machine right here. This is the real deal. This is a completely different machine from what you're getting online. It's a completely different level of reliability. Just to get into the other question that's been asked, this is a machine I would trust day and night to run unattended. In fact, I've been running many of my 3D printers for many years now, blindly. Even especially when I have Octoprint set up on the Raspberry Pi, I just sent the G code into this studio, into this basement room, sit up upstairs at my nice workstation, and do other things, and not even check the printer once. When your 3D printer is built reliably, when it's made from good components, when it's set up well, you can completely trust it, print it blindly. They do have really good safety features these days, and they are really reliable. So, like I said, as long as you have quality hardware. If you're buying one of those Chinese i3 kits, in fact, I did test Himalayan M150, which I guess would qualify as one of those i3 kits. Then I wouldn't want to have that printer running unattended, especially since it has some of the safety features disabled, and depending on who you ask in the community, I didn't actually try it. You can or cannot update the firmware without doing huge mods to the hardware. It's just, yeah. Preach it. I mean, it's the least I can do. What I'm doing now on 3D printing, I can only do because there is a community around it, and that community only exists because open source is a thing. Open source 3D printing is a thing. If we didn't have open source machines, then 3D printing wouldn't be as big as it is today. Yeah. People are asking about fans on the carriage, I believe. So the i3 has a pair of fans, as does many. The i3 has a pair of fans. Many printers have 2 or 3. Can I grab a tool head from somewhere? No. But basically what these fans do is there is one on the side that you can just barely see. It should move. Okay, just stop it. This one right here. This fan cools the upper half of the hot end. Let me just grab a random hot end. There we go, there's one. I'm just gonna hold that here. Okay, so all metal hot end, this is the one from the Prometheus system. Do have a heater block down here and a cooler up here, which are connected through a thin stainless steel part. This part up here gets cooled, this part down here gets heated, and there needs to be a temperature gradient between these two. So the fan up here keeps this part up here cool, and the heater keeps this bottom part warm. So that's the part on the side, and this fan, so that just keeps the hot end up here cool. And the fan in the front here, this radial fan, is piped down and blows over the print itself. So the PLA we're printing today is a plastic that has a rather low softening point. So if it stays warm too long, because it is basically liquid as it comes out of the nozzle, if it stays warm too long, it's going to deform your print and going to cause some ugly artifacts. I did a video on egos. Yes, I did basically a rundown on egos versus non-egos. They can work. You do have to use them right. They're great bearings. The WorldSpots use them. They work great in there. But either one can work, whether it's L8U or egos bearings. They both have their pros and cons. I like both of them if used correctly. What is the... JJB, yeah, 2 months ago I recommended this machine to a friend starting in 3D printing. He didn't listen and bought a Chinese kit. He's still trying to make his machine print to this day. Yeah, I guess that's a typical case of, I told you so! Aegis rails compared to MGM 12H rails. In that case, I mean, I do have some Aegis rails here. let's make that the last involved question. But I mean, this was supposed to be a beginner live stream, right? So you've got this sort of what are these called? I don't know what they're called. Basically, these aluminum carriage types. These are really cheap ones. They don't work well, or don't work well in low tolerance applications. Then we've got this massive sort of block. Can I show it in this camera? Yeah, sort of. These are sort of better because you can get the adjustable bearing blocks. But for these larger things, I'd always go for the MGN rails, just because there is so much that they're just fire and forget. You do have to keep them clean, but yeah, they're super precise. They're super stiff. It's just if you have the option between Eagles rails and MGN or those linear rails from any manufacturer, go for the ball bearing ones. They're just all better. How big can you print in general? It's actually, how big can you print in general? So that is a very interesting question. Because it is one that doesn't have a very clear answer to it. If you're looking at what some of the, I think that they're sort of related to Ultimaker. Some guys in the Netherlands are doing or using a building the Kammer maker, Karma maker. It's basically a shipping, what is it called? Shipping container? Yeah. Upright and filled with a 3D printer. So they've got a pellet extruder that doesn't print from filament, but uses the raw filament or plastic pellets. And it's basically, I think, like a 2x2 by 4 meter print volume. You can print like that. It totally works. The only thing is you do lose detail. That's the only thing. With something like a pellet extruder, you do have to use like extrusions that are about that thick. So you do have a limit of how fast you can extrude. That's one, of course. But the other limit is how fast you can move. And it's sort of the inverse of what you're seeing when you're going towards lower layer heights. It just takes way too long. Even on a build volume like this, which is 250 wide by 200 millimeters tall by, I think, like 200-ish millimeters, or 250 wide, 200 deep, 200 tall. If you fill that up and print even at a low layer height, it's going to take a couple of days to completely fill that out. So the larger you make your printing volume, the longer your prints are going to take. So there is a practical limit somewhere. But realistically, I mean, the biggest printers you can buy right now are like 30 by 30 or 40 by 40 centimeters, which is also the volume where you do want to start thinking about getting an enclosed build volume, which was a topic that came up earlier today. You do want to think about getting an enclosed build volume because the drafts from around your print are going to create pretty large forces on your part that will want to warm up, and even a heated bed cannot compensate for that too well. Yeah, so on the topic of 3D scanning, my experiences of 3D scanning are limited to what 123D Catch can do. Basically, what's the other one from Autodesk? That's basically the same tool. Recap, Autodesk Recap, which is a tool that allows you to just take your phone camera. Don't use your phone. Use a real camera. Take some high resolution, sharp, crisp images of a 3D part, walk around it, and it will use photogrammetry to match those images up and create a 3D model from that. That's something I've used a while ago, and while it's fun, it's not really something I saw myself doing regularly. part of the problem was 1-3D catch isn't really reliable, or like super consistent in its results either. Plus, every 3D scan does need a bit of post processing typically. That's one. Plus, what I also used was one of the rotating table scanners with 1 or 2 lasers and a webcam in the center. But the problem with those were it also didn't really work as advertised. We were getting low resolution scans because the webcam used was just the C170, which is basically a 320 by 240 pixel Logitech webcam, or a bit more than that maybe. You were getting blurry scans and lining up, even though I calibrated the thing over and over again. So it didn't really work out all too well. So in my experience, 3D scanning really isn't something yet that consumers don't really want to look into, or really invest in at this point. Hand 3D scanners. So you're saying those handheld 3D scanners that you basically wipe your part down with. That's essentially what you're doing. You're essentially wiping it with a structured light scan. Kind of expensive. If you want to get one of the industrial models that gives you like few microns of accuracy, those are ridiculously expensive. Something else like the like what is seeing in the Asus or the Kinect based ones. Basically, Asus is the same hardware. The Kinect based scanners, even if you put reading glasses on it and scan from really close up, they also still don't give you like sort of a real submicron. Submicron is probably the wrong word to use, but they don't give you super high resolution scans yet either. So you will have sort of a degradation from a physical part to a real part. Now where I can see 3D printing making, or 3D scanning making sense. I can see 3D printing making sense too. That's for sure. Where I can see 3D scanning make sense is for like those gimmicky 3D selfies. Yes, as cheesy as they are, it's I think they're a legitimate way of like capturing the moment, capturing a moment in a person's life. That's where 3D scanning is kind of cool. For making figurines, for making heads and combining it onto other things, that's something that's also kind of cool. And for artistic reasons, where you have a clay model and want to scan it and then edit it digitally after the fact. So that's something where I can see it used. But typically, like I said, a consumer is probably not going to be messing with it all too much. Right now, we are printing PLA. Thanks for the question, Jake Abel. We are printing PLA. This is Joe. If you can answer that in more detail, but this is the gray PLA that Joe sent me with the Prusa. I think you can buy it in their shop as well. It's like a. It's not a super brand name PLA. It's like a. It doesn't even have a brand name on here. But it's a decent PLA. It prints well. ABS versus PLA, good question. I'm actually finding myself printing a whole lot in. I actually find myself printing a whole lot in PLA these days. Just because it's a bit easier to print and it's a bit less smelly, depending on the brand of ABS you use. However, I still like printing in ABS a whole lot because first off, temperature stability, mechanical toughness. PLA likes to splinter and basically shatter when it's under load. ABS stretches a whole bit more before it gives in. It does have its applications. Anything that's getting hot, anything that needs to be impact resistant and tough, that's where ABS comes in. PLA does have its applications. You know, a lot of parts work perfectly well in PLA, but I don't think ABS is like disqualified for anything that you know has real use. PETG is a good middle ground, especially if you go into more of the engineering types of plastics, like E3D Edge. I think I've mentioned it every single stream now. I love that filament. It's an awesome material. It sits in between of what ABS does as far as temperature stability goes, and as far as PLA goes, what ease of printability goes. So PET usually strings a bit more, but also is awesome at bridging and usually gives you a super good print quality without much tweaking. Yeah. So when it comes to ABS or PLA, so there are good and bad filaments. I've had good PLA, I've had bad PLA, I've got good ABS, I've got bad ABS, I've got ABS that stinks, I've got ABS that you can totally not smell when you're printing it. I've got ABS that completely delaminates if you don't print it at 260 degrees Celsius. You can get either one. So, you know, read reviews, look at what you're buying. ABS can be a viable choice. And while it does emit more particles, as you know, according to the studies that are out there, it's not like PLA is super convenient to have printing next to you as well. Ooh. It might be from me talking the whole time, but I know the PLA fumes, just the particles from it, do give me a sore throat, a rough throat, and that's what I can feel right now. I do feel like it's been, since the printer has been running, it's been getting worse, but you know, I generally recommend not having a 3D printer run next to you in an enclosed space. In fact, I'm going to open up the window just to be sure now. Just for some of the fresh air. Yeah, Prusa Basic, so Joe has just clarified that. I do have to you know, rephrase it because the chat is unfortunately not going to be available as a replay when this thing goes up as a recording. This is the Prusa Basic PLA, $20, a kilogram spool. So yeah, is it a full kilogram? I think so. Yeah, 1 kilogram of filament, $20. That's pretty good. It prints pretty darn well. PLA smells like brown sugar. It smells, I wouldn't say it smells like brown sugar. It smells sort of like burned sugar. That's the thing. This is printing at 210 degrees Celsius right now. Typical ranges for PLA are anywhere between 185 to 220, 225 degrees. Some of the more engineering PLAs, like Tallman's in PLA, I have printed at 240 degrees Celsius, just because it didn't get any sort of layer adhesion below those temperatures. But typically, 210 degrees should be kind of okay. Do I have any ABS to test with? Yes, I do. I have Esan ABS, which is crap, and I also have some. Where is it? Where is it? Over there in the corner. You probably just. Oh, you can see. I've got some generic white ABS, which prints beautifully. And some Hungarian, I have no idea, green and blue ABS, just to have a bit of a variety. I do eventually use that for things that sit outdoors, especially the black ABS. Black ABS is actually very resistant to the elements. I've had ABS sitting outside for years in the bright sunlight, and not show any sort of degradation, just regular plain old black ABS printed on regular settings, regular machine, and it's sticking up very good. So that's an application. ABS definitely has its uses for it. PLA does melt if you leave it sitting in a hot car. Just to recap on the stream for the people that are just now joining in. So we are actually towards the end of the stream already. So Prusa, original Prusa i3 MK2, not a China clone, the real deal. That's the printer we're printing. We are printing a belt clip for for this guy right here. This is the Zoom H4n that I use to record my audio right now, and that I use to record audio for most of my videos. It does not have any way to transport it other than to stuff it in your pocket. So I'm going to be making a belt clip that sits right here where it's mounted to the Gorilla Pod, and that is what we're printing. PLA Prusa brand, gray material. Esan ABS, so it's, I guess I could turn this one on. Let's just do it like that. Esan ABS, so I only bought the Esan ABS because I was hearing, nothing running out of battery? I don't know. Because I was hearing people praise Esan PLA. The problem with Esan ABS is, as with many cheap ABSs, you either have to print it at insane temperatures and 260 degrees or 250 to 260 degrees, and then have it running out of your nozzle and melt the entire print, or you print it at low temperatures and get no layer adhesion but clean prints. So it's sort of a trade-off. Either you print it super hot and messy, or you print it cold and your prints will fall apart. And that is one of the main downsides with ABS, unless you print it with the exact right settings. You can get layer delamination very, very easily. The MK2 parts on this printer right here are printed in ABS. Also a Prusa brand, or at least an ABS made in the Czech Republic as far as I know. 3D printed parts should always, how much will I cover in the electronics cover or PET? Okay, good to know. Anything that is used in a 3D printer, or for mechanical stuff that's supposed to last, I would always print from ABS. PLA is known to degrade after a while, after like 2-3 years, to start delaminating. So stuff like that, especially the stuff that's getting hot in the hotend area and in the build area down here, I would always recommend having that printed from ABS. Jamming hot ends, yes, it's an issue. So let me Nightbot is active. Let me just try this out. So I want to do a poll. Let me just see. No. Okay, so people have been commenting about the E3D V6 jamming with PLA. I personally, this is not something E3D is sponsoring me to say. I have personally never had an issue with PLA and E3D hot ends, whether it's the V4, the V5, the V6. Never had a jam that wasn't completely my own fault when I got particles and stuff in. Oh, awesome. Hold on. Just write it in chat. you get the idea. So let me know, did your E3D V6 ever jam? That's the question. I have never had an issue with it. I've heard people talk about it. I've heard them talking about it, jamming if they don't prime it with oil, with canola oil first or anything, but I personally never had an issue. Poll did not work, yes, unfortunately not. Okay, yeah, poor cooling causes jams with PLA. So that's now keep in mind, this is not asking about E30J heads that you can get from AliExpress for $6. This is asking about the genuine E30 V6 that you buy from E3D or Philips Studio or some legit reseller. I've looked at some of the Chinese, you know, that they're sold at E3J head. There is no such thing as an E3J head. I've had a look at those. Those have completely different heat breaks, rough on the inside, sometimes incorrectly assembled. Those will jam, let me just tell you, but the original one should be a bit of a different story. Lag between chat and video should be around 15 seconds. I did measure it last time. I think it should be similar this time as well. Okay. So one of the questions that does come up and that I've had ever since the I've had too ever since the Prusa i2 came out, or the original Prusa or whatever one it was, that had two independent motors. Oh, my camera's gone. 1 second. And we're back. One of the questions that has been coming up ever since the two independent Z-axis motors idea came up was, but what if they lose their synchronization? So what the Mark II is doing in the printer calibration step, basically, it's letting you ram the Z-axis against a screw up here. So it will have you skip the Z-axis motors and, you know, basically jam it up there and resynchronize them that way. If they do skip, and if one of them does lose positioning during a normal print and you don't catch it, well, then the auto bed leveling will compensate for it to a certain extent. However, you know, if it's too far off, it will jam on any printer that uses dual independent motors. Whoops, that's the wrong direction. It will jam, it will cause some issues, and it might break something actually. So just keep an eye on them. If your machine is well tuned, if it's well oiled, like we said, grease your linear bearings, your rods or regularly, and keep them well maintained. Then you shouldn't have an issue, and it shouldn't be shouldn't be skipping at all. All right, so the print is done. Now to jump back into the, yeah, still doesn't look like a frog, yeah. Still haven't gotten an AC adapter for that camera yet. I do have one for this one, but not for the other one. Pony, frog, yes. I do not know an animal that this would look similar to. Oh, let's just... You guys a bit zoomed in. So the print is done. There is one line down here, which is a bit of over extrusion. Again, this was the fast profile. This was the sketchy and fast profile. So it's not printed for quality. It's just printed to get it out as quickly as possible. Yeah. Layers, yes, I think these were around 50 layers, 50, 60, 70 layers or so. Well, I could do the math. That would be too easy. It's more than 50. It's a bit more. 0.3 with a 30, it's 100 layers, exactly. There's the math. Weird frog, yes. Now, let's get back into 3D printing basics. So, print is done. Ah, perfect. MK2 will actually tell you if the Z-axis motors are out of sync. So the print is done. Now, what you of course instinctively want to do is to grab the print and rip it off. That would be wrong, and you could actually damage something. So at this point, first off, I did ask you guys before if you ever had a filament jam in your E3DV6. The easiest way to get a filament jam is to turn off the power immediately after the print is done. You don't want to do that. You want to leave the power supply on. You want to leave the printer plugged in. You want to give the hot end a chance to cool down. So if you look at the, this hot end again, you got the hot zone down here. You got the cooler up here, and you've got the fan on the opposite side. So this fan actively cools the heatsink up here, and this part up here, the heatsink, is where your filament is going to jam if it gets hot. Down here it gets molten again. That's okay, but if it gets too warm up here and actually deforms, that's not going to heat up again. That is not going to liquefy and move out of the way. So leave the printer plugged in, let it cool down, take a look at the LCD display up front, and there we go. Let it cool until we're at 65. It would be okay to shut it off now. In fact, I think the fan will turn off in a second as well on its own. That is a way to mess your printer up. The other thing is, don't instantly pull the material off of, or the print off of your bed. Especially, or if you have a heated bed. If you have a cold bed, then it doesn't matter. If you have a heated bed, it does matter, because most heated beds are designed in a way where you get adhesion while it's hot, and then it lets go when it's cold. This one has a PEI sheet over this thicker PCB heater, so it doesn't need the glass. That's that question answered. It doesn't need the glass, and PEI especially is very, very good in that regard, in grabbing onto a print while it's still hot and then letting go when it's cool. So ideally, you want to let this cool down as much time as you have, with as much time as you have. But typically, like around 35 degrees or 30 degrees ish, it should be okay to remove. Yeah, compression air spray the bottom of the model. Yes, that also speeds things up. Yeah. Now there was one more question on the elephant's foot on prints. Let me just see if I can find this on a model I have printed. Let's see, because I know exactly what you're talking about. If I could find one. Anyways, I don't have a Benji that has an elephant's foot. That is interesting. Sorta. Yeah, this one sort of has it, but this one sort of looks like crap. Anyways, so there's an old print for you. I guess you can. Come on, you can kind of see what's up there. So, obviously the print looks like absolute garbage. That's an old print from the OPAM hot end test. So that there's this ridge down here. There's this section where it curls inwards, apparently back here as well. So that's a combination of two things. So first off, you got, this one is, you can sort of see it, the first layer is relatively thick. That's one, but that doesn't matter too much. The problem that's mostly causing this is a heated bed that is too hot. So it will actually soften the lower settings, the lower layers of that part while it's still printing, and have that curling inwards, while the upper layers aren't affected by it too much. Now, if you had the entire part at that temperature where it curls for those lower layers, then the entire part would just look completely awful. But in this case, it's just the first few layers that are affected. Which is why you get this sort of an elephant's foot. So basically, get a better bed adhesive and lower your bed temperature. Simple fix for that. Can I do a full calibration on the MK2 for new people like me? If you want to get the full MK2 experience, you can watch the full live stream actually. But, oh wow, that is nice and rigid. That is super rigid. But I don't know if that would fit in here. All right, so let's switch that over here and turn that off. Delta versus Cartesian. There is, hold on. Both can work. Watch my review of the Atom 2.0. Both can be wonderful printers. All right, so the part is done. Now, let me just give you guys a quick view of how that turned out. Because I think, so the camera, work with me. There we go. So, as you can see, the overhang down here actually turned out pretty well. There is no curling, no inwards, no inwards warp or anything going on there. The holes in here also, as expected, the upper two layers did curl down a bit. That's exactly what I predicted. But it's not a problem because, you know, the top layer is still bridged across it pretty much perfectly, and the same on the inside part right in there as well. Now, the smaller hole came out a bit better because it doesn't have that much of an overhang, that many layers of an overhang where it has to bridge it. So this one is basically round, and if we take a look with the calipers, this is supposed to be a 7mm hole, and it measures to 6.8 millimeters. Roughly, let's just get that on camera real quick. There you go. There's your 6.8 on the nominally 7mm hole. So, for those of you asking about the precision of those sort of prints on holes, it's not a huge deal. Typically, you're gonna get really close to your final dimensions. Yeah. Now I would love to try this part because, you know, that would feel sort of incomplete if we didn't. Let's just see. So first things first, let me just flip that around real quick. First things first, so the camera does swivel. So the screw in here, come on. Alright, screw that camera. Let's use the other camera. So the screw in here, this one has a better autofocus apparently. The screw in here fits pretty well, so we're almost flush as expected. And on the other side, let's just jam my finger in there. On the other side, we've got the thread sticking out just perfectly. Now, what should we do? So we do need to screw this thing to the audio recorder, but I will need to plug in a microphone or it will be kind of noisy and annoying for you guys. So let me just get a lavalier real quick. Because I don't want to make the audio unusable. I'm hoping this is going to work. I'm hoping I can just live plug this thing. I should have tested it beforehand. I know. Whoa, there we go. Try not to make too much noise. Okay, whoa, that is loud. Is that too? That completely clips. Okay. That doesn't work. I will try to be sort of careful here. Let me know if it gets too loud. And oh yeah, that definitely clipped. Let me know if it gets too loud and we'll stop the experiment right there. There goes my subs. You know what? Let me try something else. Let me see if we can use the webcam's audio. That should be independent from that. That also seems to clip. Move, yes. Okay. So I'm hoping this doesn't. Yeah, that looks better. I'm just gonna move this camera. So now it's the webcam that's doing audio, and not the H1, which we should be able to unplug. But let's just see how well this fits, because I wouldn't want to go out. Yeah, lavalier worked. Yeah, so we've got the screws sticking out properly back here. Why no autofocus? I don't know. Let's get this thing in here now. I don't think I'm gonna be. I can actually get in here with the knife. That's cool. Rode Smart Love, yes, they're awesome. And they're cheap. That's probably more important for me. I think I do need to get a screwdriver for this. Let me just sprint over to the workshop real quick. All right. There we go. So that fits. Now the only problem with the 8 frame is it has a little dimple right against where the where this thread sits. So it only sits flush against the case on that very dimple, and not anywhere else. Let's see if I can unplug this. It doesn't crash OBS Studio. So let's see if this works. I mean, physically, it looks awesome. It looks pretty darn great. Let's see. And it actually does work. Look at that. It actually fits, and I can jump around and stuff and not have it fall off. So I think I can call that 8 an absolute success. I think. That's awesome. So, you need a clip for your 8 frame as well. In fact, this clip should be mostly universal for anything that has that 1/4 inch tripod screw. Hey Bob, nice to see you here. Yeah, but we are pretty much done here. Yeah, clip works, clip printed well. Nice little project for a stream like this. This thing is gonna make my life a whole lot easier. I'm gonna be using this every single video, every single time I record something. Yeah, till it gets brittle. Well, we'll see about that. I can always reprint it in ABS if I need to. Okay, resolution is crap. Yes, it was a fast print. It was a. Let's just get that wrong camera. Resolution is crap. It was on the fast print setting, so that's 0.35 millimeter layers. It is, you know, on the very fastest. I don't need any sort of resolution here. I just needed to work. I needed to function. I needed to you know, be a bit flexible right there, and it is. And I'd call it an absolute success. Yeah, so that is. There we go. We've been using it for a while. Yeah, that is about it for today's guys. So, as always, thank you for joining in. If you found this, is it a guide? Is it a walkthrough? If you found this video helpful, I would appreciate a thumbs up. I would appreciate if you would share it with people that you think might, you know, interest this sort of a peek into 3D printing, into how the entire process works. I know that there are many steps that you can tweak, you can make easier or harder on yourself. I just decided to go the full way and show you every single step. Typically, you know, a stream like this, a process like this, from the idea to the finished print takes me, you know, the longest in the printing phase. Design, once you get the design phase done, or once you get the way of thinking down for how you can design something from the idea you have in your mind, it's really simple. Just, you know, pick a tool, try a few different ones out, learn one really well, learn how to use that one, and I think that is, like I always say, making your own designs and you know, working with your 3D printer is pretty much the best use for 3D printing, instead of just downloading things from the internet. That can be cool and all, but this is how you can really make use of these awesome machines we have these days. All right, so fix your audio back again. I will be fixing that for the next stream. I will be using the H4n again, so this one is obviously disconnected now. Webcam is doing the audio, but next one is gonna have the good audio again. This was just impromptu. Anyways, yeah, thanks for watching. Get subscribed, like, do whatever, you know, what they usually say. Patreon, yes, I have Patreon. So if you kind of really enjoyed it, head over there. Next live stream is next weekend. And until then, oh yeah, next live stream is next weekend. We are going to modify the Atom 3D. We're going to put a smoothie board in it. I think it's approved by Adam, and Arthur Wolf has already sent a smoothie board and an Android tablet my way. So definitely check that out if that's something you want to see. We're going to go through the entire hardware and software modification and just yeah, see how well it goes. All right, so that's it. Thanks for being here, and see you next time.